This is a video on partial fractions and type 1, so just a bit of an introduction. Sort of thing you might see at GCSE is going to be this, where you have to join these two terms together and you'd find the common denominator. So how do we do that? We times top and bottom here by x plus 4, so it'll be 2 upon x plus 4 all over x plus 5, x plus 4 plus 3 upon times and top and bottom this one by x plus 5 all over x plus 5 and x plus 4. Joining the two together then, we now have our common denominator, so x plus 5, x plus 4, and then on the top I'll do a wee bit of work in here, but we're going to have a 2x here and a 3x, so it'll be a 5x, and then we have 2 times 4 which is an 8, and a 3 times 5 which is 15, so it'll be 5x then plus 23. Partial fractions is the opposite of what we've just done. You start with this and you want to split it up into its partial fractions. It's handy for a lot of integration and things like that a little bit later on in the course, but that's the idea. You start with something like this and you end up then with this. Let's take a wee look at the first example and see if we can make a wee bit of sense out of it. This is type 1, where it's linear factors only in the denominator. This factorizes, so really the question we're going to be doing is 5x plus 1 all over, and I hope we're okay, we're at a stage where we can factorize this. That's going to be, what's that, I think it's x plus 2 and then x minus 1. So if there's going to have two linear factors, as you can see kind of from the example just up above, if you have an x plus 4 and x plus 5 here, obviously over here then it's going to be two separate bits. So the way we set it up is as follows. We go for a over x plus 2 plus b over x minus 1. And it's our job on this to work out what a and b are. Common denominator again then for this. So that's going to be a upon x minus 1 all over x plus 2, x minus 1, as I always say. This is just this written out again, however, times top and bottom by the same thing, so it keeps it the same value. Times in this one here then by then x plus 2. X plus 2 upon x minus 1. If we join them together, we will have a upon x minus 1 plus b upon x plus 2 all over x plus 2, x minus 1. So here's what we started with, 5x plus 1 upon these. And notice this here equals signs down to here, so this must be the same as this. The bottom lines are the same, so the top lines must be equal to each other. So our next line from here then is, just about to see that, can we? 5x plus 1 equals a upon x minus 1 plus b upon x plus 2. As I said, our job was to work out the a and the b, so we're getting close enough to doing that. We're nearly there. If we let x equal certain values, we should be able to eliminate some of these letters and work them out. So that's one method of working these out. I'm going to let x equal 1. If you put x equal to 1 here, we're going to get 5 plus 1, which is going to be 6. Note I've let x equal 1. See why I've done that? So that this bit is going to disappear. And I end up then with 3b. 1 plus 2 is 3b. That gives me then a value, obviously, of b equals 2. To try and eliminate the b, you could just sub in the b equals 2 and then x equals 0 or something like that, but to eliminate the b, we're going to go for x is minus 2. So if it's minus 2, that's minus 10 plus 1, so I think that's going to be minus 9. Minus 2 minus 1 is minus 3, so it's minus 3a. That gives us a value then of a equals 3. We're pretty much there. The question asks to split 5x plus 1 all over x squared plus x minus 2 into its partial fractions. We've worked out that a is 3, so we're going back up here. We're going to have 3 over x plus 2 over x minus 1. That's this split into its partial fractions. These two things are equal to each other. Obviously, otherwise we couldn't write the equal sign. Let's take a wee look then at the second example. You can see then there's 3 factors here. It's already been factorized for us, but there's still a fair bit of work to do. again, I hope you can take a guess as to what we have to do next. We're going to have a over x minus 1 plus b all over 2x minus 1 plus c all over x plus 3. Stick a bracket around here. We need to try and find the common denominator. We have a bit of writing here, so hang in there with me. We're going to times top and bottom of this one by these two factors here. So it's going to be a upon 2x minus 1x plus 3 all over x minus 1, 2x minus 1, x plus 3. As I always say to people, what have I done here? I've times top and bottom of this one by the same thing. So that's why I can put it as equal. Plus b, we need to times this one by this one and this one. So x minus 1 upon x plus 3 all over x minus 1, 2x minus 1, x plus 3 plus c times top and bottom by these two then. X minus 1, 2x minus 1, and as before, x minus 1, 2x minus 1, x plus 3. To save me from writing here, I'm going to leave out this next line, but it will be putting everything over the same denominator. The three denominators are the same, so we're going to write this out once and then have these written 3 times. As with the previous example, if you look, then this line here must equal the top line here, so that's the next thing then I'm going to write out. So we're going to go for 2x squared plus 12x minus 10 equals a upon 2x minus 1 x plus 3 plus b upon x minus 1 x plus 3 plus c upon x minus 1 2x minus 1. I'm first of all going to let x equal to 1. Hopefully we can see that's going to eliminate this one. So if you times b times 0 times whatever, and again c times 0 whatever, these two bits are going to disappear, so we should be able to work out our a. So just make sure I don't make any arithmetic errors here. So instead I'm going to let x equal 1. So if I put x equal to 1, I'm going to get 2 plus 12, take away 10, and that's going to give me a upon 1 upon 4, so that's going to give me 4a. That means a equals to, this is 2 plus 12, which is 14, take away 10. So my value for a then is going to have to be 1. Next thing I'm going to do, I'm going to let x equal minus 3. So again, just be careful here. So if x equals minus 3 squared is going to give me 9, so that's going to be 18. Take away 36. And then take away 10. That's going to equal, that's going to disappear, that's going to disappear. I'm going to get c then upon minus 4. Goodness. C upon minus 4, and then if it's minus 3 here, I think that's going to be minus 7. Hopefully this will work out. Minus 36 minus 10 is minus 46. And taking away then from 18, so that's going to give me minus 28. That seems like reasonably good news. Is equal to 28c, and so c then gives me a value of minus 1. I can of course sub in a and c and just put x equal to 0 here. That might be our way to go, or the other option then is put then x equal to a half. So I'm going to sub these in and then let x equal 0. So if we go for x equals 0. If x equals 0, this bit disappears and I end up then with minus 10. That's a 1 because we know that. That's a minus 1. And what do I put in x equals 0? And that's a 3. Plus b upon minus 1 upon 3 plus minus 1, which is our c of course, upon minus 1 upon minus 1, excitingly. So I have then minus 10 equals minus 3 minus 3b minus 1. You still see this okay? That gives me 3b equals, that's minus 4, taking this over, then it's going to give me plus 6, and I'm going to get a value of b equals 2. That seems promising, as if I've got it right. So we're almost there. We've worked out that a is 1, c is minus 1, and b is 2. So my initial question said split this into its partial fractions. So that was 2x squared plus 12x minus 10 all over x minus 1 upon 2x minus 1 upon x plus 3. And that equals in a, which was a value of 1 over x minus 1 plus b, 2 over 2x minus 1. And then c is minus 1, so rather than put the minus 1 on the numerator, we just write a minus here and then a 1 and go for x plus